Hey guys, Martin here with my own two hands and another project. And this one is a little bit special because we have to pick it up in our flat first. And it's a project that I've neglected for two and a half years. So it is really time to do something about it. And luckily enough, it is not a family project. It's not a wife project. So I didn't have to hear about it for 2 years. It's only project for me, more or less, and so the only person I have to hear about it is me, which is bad enough. But today is the day, and we are going to pick it up, take it into the workshop, and do something about it. Yeah, let's do it. Don't mind the ugly door. That's not what we are here for today. But we are here for this thing, this metal enclosure. And it is actually called a control panel, and it is a box for electrical stuff mainly used in industrial automation. So it is slightly different from the other box, this one, which holds the circuit breakers, energy meters and stuff. So I'm using this one for my home server, some home automation, internet related things and so on. And that's what we are going to fix. Okay, so are you ready? Viewer discretion is advised because the pictures you are about to see are pretty graphic, but yeah, let's do it. Oh my god. Okay, so I have to say that this looks pretty normal and on par with the job sites I was working on. And I'm almost tempted to say that I'm not shamed by this, but yeah, it is quite shameful state. So what do we have here? I have here somewhere under this nest of cables there is a internet router. I have a power supply for the access point I have in the kitchen. This thing, this dangerously looking thing, barely working, is my home server, which actually works fine for many years, but it really deserves a better configuration. Here I have a 24 volt power supply, which is powering the LED stuff I have in the flat. And these red cables are connected to places where I expect some future home automation things, like for example the LED strips, so I can dim them and control them from some remote places, and some other stuff. And yeah, there are a couple of LAN cables which I use for different computers in the flat, and this is just a power strip connected directly to a 230 volt input I have from the box right next to it. And this big black box is uninterruptible power supply. All of this has to go down. I still have to keep the internet running and the Wi-Fi running, so I'm thinking about having some sort of a small shelf where I will keep the router and keep the Wi-Fi stuff, but everything else will go down. I will take it down to my workshop, and then I will talk about all the different things I have here and all the possible future things I would like to have here. So I'm disconnecting everything, starting with the server, then I'm unplugging all the LAN cables from the router, and luckily enough I have them labeled so I know where they go in the flat. And so it goes for the red cables for the home automation. There is a lot of them, but I'm using like 2 or 3 places so far. I'm unplugging the control panel from the power, from the distribution box right next to it, taking down the extension cables and so on, and now I can take the box down from the wall. And I need the internet running, so I'm adding this small particle board shelf that's held by this string, and it won't hold anything heavy. It's just a router and power supply and extension cord. Okay guys, back in the workshop. I have the metal enclosure with me and everything else which I will need for the rebuild. And the metal enclosure actually comes with this mounting plate. So it is a plate where you can lay all the things you want inside, you can screw on it, and then when you have everything prepared you can just put it inside and screw it in, well, into the control panel, I guess. So this is quite nice to have, and I'm surrounded by all the things I will need, which you can't see. So from this corner I have the UPS, the uninterruptible power supply, which is this box. This box has three European plugs for 230 volts. There is a battery inside. It can hold I don't know, for 10 minutes, something like 100 watts, which is okay for small servers, for small computers, home use. It has this European plug, which I don't like, and I will get into that very soon. And I have the replacement battery, which I will also talk about. It's like this is the overview of what I have here, what needs to go inside, and then as I will be building this, I will talk about each part a little bit more. So the UPS, it is heavy. 24 volt DC power supply for the LEDs I have in the flat. Here I have a box of terminals. Terminal is this small thing. It is a Vago terminal, and it is made for connecting 2 or more wires together safely and semi-permanently, so you can plug the cables in and unplug at any time. They have these notches at the back, buenas notches, and these are for the DIN rail. That's this bended piece of metal which can get screwed on the mounting plate, and then you can click very easily the things wherever you need them. Like click and it's done, and click and it's done. On the left side I have a box of other things, and these are network related. So I have a lot of networking cables, like 6-7 networking cables that go inside of the control panel, like internet, different computers in my home, and so on, so on. So you need these cables to be terminated, and it's not a good idea to terminate them with the RJ45 plugs, but rather with something like that. So I have these keystones. These are plastic pieces. The cable goes inside, and you have the female RJ45 connection. So I opted for the keystones, and I want to be plugged them on the DIN rail as well. So I found this, found a model for these keystones. So you can, like that. Is that correct? No. How the hell it was? Like that? No. I'm experiencing some technical difficulties, but ta-da! It is a box for the keystone, which is also mountable on the DIN rail. What do we have next? This, for example. So this is a how do you call it? It's like a plastic channel for cables. So you cut this to size, mount it onto the mounting plate, and you have devices up and below this, and you can have cables going into the channel, move left to right and come out anywhere you need, and all the cables are nicely tucked in. So this is like a cable management thing. And last but not least is this thing. This is actually my home server with a custom 3D printed enclosure, and it is designed, and it was actually my first video I made for this channel about this enclosure and about this server, and throughout the time it doesn't look to be the best idea, because the plastic just melted, like slightly bent under the heat of the equipment inside, and it just doesn't hold everything nicely. I have this back panel which I'm quite proud of. This is the 230 volts with some switch, the Ethernet and USB connection for the UPS. And on front I had a very similar panel to the back, but yeah, I left it at home, I think. It doesn't work the way I would like to, Jesus. And this is the thing which needs a rebuild. So I decided to design holders for the power supply, which can be put on the DIN holder again. I have some holders for the hard drives, which can be mounted on the DIN rail. And I have a much nicer box for the motherboard, which can be put on the DIN rail as well. So that's like the outline of this project. And yeah, let's start with the server. Let's put everything on the plastic holders to see what is the size, what should be the distance between the components, because some cables are quite short. And yeah, that's something we can start working with.
So let's start with pulling all the components out of the box, and they were held inside by these plastic rails which just melted off. This is the motherboard of the server. It is quite powerful for its size, and I already prepared a new power supply with the DIN rail holder. And let's continue with putting the motherboard into the new enclosure, and I designed it in a way that these two parts are screwed together, but I actually broke off these standoffs for the screws as I was screwing this together. So I decided to glue these two parts together, and they have this nice half groove edge, so it nicely accepts the super glue, and hopefully it will hold.
I am amazed how this turned into amateur hour very, very quickly. Like, I didn't expect that to be that quick. I expected that there will be some problems along the way that will make me look like an idiot, but that fast? Yeah, I didn't expect that. Okay, so let's hope that this will turn out okay. Come on, that fast?
So the next part are the hard drives, and I designed and 3D printed this plate which clips on the DIN rail, and it has this springy mechanism to hold it on the DIN rail. And for the power supply I designed something very similar, and you can buy DIN rail power supplies, but this is the one I have, so why not to use it.
So I'm thinking about the disposition of the things inside of the control panel for some time now, and I think I came into a conclusion. On top here, on this top, we have to have the input-output terminals, because the idea of the control panel is that you have some very defined connections, and any cables or wires and devices that needs to be connected to the control panel has to end up here in the I/O terminals. So here on the top I will have the terminals for the 230 volts. I will have the LAN connection, which is like 5 or 6 cables, and I will have the terminals for the home automation thing. And then all the cables will go further down from the terminals and from the keystones further down into the control panel. And it is pretty common to have another set of terminals which are for interconnecting the devices inside of the control panel. So I will have a vertically mounted DIN rail with these connectors, and the idea is that the 230 volts will go here and then will be distributed to the power supplies, the UPSs, and so on.
And then I went on about the intricacies of building a control panel, and let's skip that and dive into the build itself. So I'm cutting these plastic cable channels down to size with my wood saw, and let's do some final, semi-final layout and mark the final length of this DIN rail. And I'm cutting this on my metal cutting saw, and this machine, I just like it because it's fast and it's easy and it's just pleasure to work with. It's noisy as hell, but it's far better than the grinder. And we need some holes to be drilled into the DIN rails so we can mount it on the mounting plate. So these are just a through holes for M4 screws. And let's mark all the holes that are needed for the mounting plate. And I'm using this combination drill bit with the thread tapping, and this is for M4 screws. And I'm using a button head screws, which I find much better than this self-tapping. They have a wider head, so they are able to hold these plastic channels much better.
Okay, so the DIN rails and the cable channels are in, and I just had to put it inside of the box with a couple of things just to see how it fits. And the UPS, it fits just barely. It's like 3-4 millimeters from the cable channel, but that's okay. What is a bigger problem is this keystone. So I put the DIN rail as close to the edge of the mounting plate as possible, but I forgot that this is quite low and quite tall, so I won't be able to put the cable in. Now I have two options and I have to combine them, I think. I should be able to move the DIN rail like 10 millimeters to the back. I can mount this terminal upside down, and maybe I will be able to put this a little bit up, the whole DIN rail. So I will put some washers underneath just to help it a little bit, like 2, 3, 4 millimeters maybe, and it should help. Okay, so yeah, let's do that. But you don't have to watch it, don't you? Just make it and it's done. Magic.
And here is the result. There is barely enough space for the cable to the cable channel, but I hope that I will manage to get in there. Let's focus on the input terminals. The first three, the black, blue and green/yellow, is for 230 volts, and this red one is for 24 volts for the first light. The green one, the gray one and the orange is for communication, and the blue one is for ground. And yeah, let's populate the rest of it. And this section further down in the control panel is for distribution of the power. So I'm wiring all this stuff together, and I have the 24 volt power supply also in place, and I'm wiring the output of it to these input terminals so I can distribute the 24 volts to all my devices in the flat.
So I took the 230 volts and I go to this set of terminals, and I'm distributing the power to the 24 volt power supply and to the access point power supply, which I mounted here. And I also will go to the UPS, so the UPS will plug over here. This set of terminals are for the 24 volts, and currently it goes to these terminals over here. And I will be powering the router from the 24 volts as well.
And that's quite enough of that. So I spent a lot of time with the LAN cabling because putting the keystones on the end of the cables is just a tedious job. Luckily enough, there was only 5 of these cables. And on the other side, I put the RJ45 connectors with this color coding sleeve, so I know optically where everything goes. And now it's just a matter of connecting all the devices together, and the box is ready to be put back on the wall.
Okay guys, so the rebuild is finished, and yeah, it took way more time than I originally thought it will, but let's hope that everything will work just fine. So, something is clicking. That means that's this UPS, I think. No. Server is running. UPS is running. Now the UPS is testing the battery. It's called self-check. Self-check is finished. And yeah. So it looks like everything is working. Excellent. Okay, I let the server run yesterday without the UPS for a day, and I measured the temperature of the hard drives and the CPU, and it was like something around 8 degrees of Celsius lower than the original temperature. So this location above the vent holes, the vertical location, not the horizontal, everything helps with pulling the hotter air out of this box. So yeah, that's what I was aiming for, and yeah, it looks like this can hold up for another 2.5 years at least. I have to finish with the labeling, and I think I can call it, yeah, done. So thank you very much for watching, and let's do something else. Bye.